This video is going to show you how to simplify very basic radical expressions. So I want to first show you the first rule of these. If I have a to the power that is a fraction power, how we would write that is this n right here represents the root. So it's the nth root of a to the m power. Or sometimes you may see it as the nth root of a to the m. Both of these represent the same thing. So let's look at an example where we would use that. If I have 16 to the 3/4 power, we can rewrite that as the fourth root, because the number that is in the bottom, the denominator, goes there, and then we will cube that answer. So the fourth root of 16 is 2, because that's 2 times 2 times 2 times 2. And then we keep our third, and now we will apply that third power, which is 8. If you want to look at another one, we've got here 625 to the 5/4. We have the fourth root of 625, and then to the 5th power. So the fourth root of 625 is 5. So we have 5 to the 5th. And off the top of my head, I couldn't get that. I need to use a calculator. So 5 to the 5th power is 3,125. That would be the answer of that fraction power. Okay, let's look at one more. So I have 27 here to the 4/3. We'll take that cube root of 27 to the 4th power. The cube root of 27 is 3, but I still have that 4th power, which then would end up being 81. So one last thing I wanted to show you is how to simplify radical expressions when you just have the root here and you have one term inside your radical expression. So what you want to do is you want to look for perfect squares that can be factored out of the radical expression. So what I do is I start with my first term, my 4. Is there a perfect square within 4? Yes, there is, because 4 is a perfect square. So the square root 4 can be written as 2 times 2. So that means that on the outside I can have 2 outside of my radical. The next term is I want to look at the x's. Well, x can be written as x squared times x. Since x squared is a perfect square, if I take this and square root x squared, I end up with an x. I can't square root the other x, so that will stay inside of my radical. And then my last term is this y to the 6th. I actually can, if I were to square root y to the 6th, it would be, if you're having trouble seeing that, you can think of it as y to the 6th to the 1/2 power, and you multiply that, you get y cubed. So you'd end up with y cubed here, nothing from the y inside, so the final answer would be 2x y to the cube square root of x. So you need to try and pull out all the perfect squares that you can pull out, along with all of the non-perfect squares that need to stay inside of the square root. Let's look at one more here. We have the square root of 200. I will try and combine all kinds of different things on this so you can really see. x to the 5th, y to the 11th. And I want to write these as perfect squares, or as simplified as I can, by looking for perfect squares to pull out. If I look at the 200, does 200 have a multiple that is also perfect square? Yes, it has 100 times 2. So because I can take the square root of 100 evenly, that would be 10. The 2 I cannot, so it has to stay inside my square root. Right now, if we look at the x, even powers have perfect square roots. So this would be, look for one less than the x to the 5th, which would be x to the 4th, times x. Well, the square root of x to the 4th, really you just divide that power by 2, so it would be x squared. So the square root of x to the 4th is x squared. The remaining x has to stay inside. If we look at the 11, y to the 11th, that's y to the 10th times y. One of those has a perfect square root. It will be this. It will be y to the 10th, which is y to the 5th. So y to the 5th comes out because it's a perfect square and the other y stays inside.